Welcome, everybody. Tonight we're going to be working on Module 7, and we have quite a number of slides to go through here. But we are talking about advanced features of objects and classes. The general agenda for this module is this. So this is the stuff that we're going to focus on topic-wise. Inheritance, which is a really important concept for working with objects. We'll learn how to do overrides, compare those to overloading. Those are two different things. We'll learn about the ToString method. We'll learn the meaning of the keyword static. We'll also figure out what is aggregation and what is an abstract and what is an interface. And this is some pretty heavy stuff that we're going into here conceptually. But it builds on top of this whole concept of objects and classes that we've been looking at so far, right? What we did learn, if you want to do a really quick little review about objects and classes, is that we can create a class file that has non-executing code, right? Which becomes a blueprint for creating objects in memory with the same features as the blueprint, but it's the actual instantiation of the class, right? It's kind of like the house is the real version of the blueprint, right? The object is the real version of the class. Now, there's a little bit of confusion with terminology too, because classes, because when we just create a program and we want to do like console write line, we're still creating a class. But what I showed you last week is we are obscuring that in the interface. So like when we do any work today, we're going to do it where we can see the whole namespace of the program, kind of like we did last week. So one of the first steps I'm going to do here is I'm just going to preemptively get myself ready to do all the try it out exercises, because there's a whole bunch of them in this PowerPoint, which is why it takes a little bit longer. So you guys, if you want to follow along, you can do the same. One of the reasons why you really want to do this, honestly, is because some of the stuff that we do can probably be copied to either complete labs or the final project, right? Conceptually, we're doing similar types of things. We are building a C# console amp for Windows here. I'm going to find my regular storage location that I'm usually using. And we'll select this folder, and then we will call this mod 7 try it out, right? So all the PowerPoint lecture stuff. I'm going to go ahead and click next. And I am checking the do not use top level statements box, which to me is opposite of what it means. But by checking that, I will see the whole namespace of the program and the main method and the main program body. And we want to do that on purpose today. And in fact, before I even dig into the, more of the PowerPoint here, I'm going to do a little micro presentation on how we're going to kind of proceed here today, just to give you a good, strong underpinning, because I did this last time too. It's not something we have to do, but I just want to show you that there's kind of some strategies you can employ and then keep all your Module 7 examples together in one spot. What we did learn, right, is when we're looking at a program like this, and we can see the namespace and we can see the internal class, which is the main program, right, the executing program that does have a main method, and whatever code goes inside here will trigger to run when I hit this green play button. It's the executable, right? It's the thing that does something. All right, well, that's cool and great to know, but we're going to do a bunch of different try it out. So we're going to have like basically situations where I want to run a little micro program, but I don't want to have to recreate things over and over again. Then I'm going to build on my examples, and I don't have to want to redo it over and over again. So I'm going to do all my work in this one file, and I'm just going to do a really quick little example here where I'm going to do like a static void. Okay, I'll be really snarky and do whatever. You guys know kind of my bad sense of humor here, and and let's just make it a console write line and say, hey, whatever It's the holidays. Oh, yay. Something like that, right? Uh, and, and the point is just to have something to run, right? So what I'm going to do here is when I'm going to be creating my try it outs, I'm going to create functions. This is a function, right? Um, and the function is going to act like our main program body for my little micro program. So I'm going to do all my like my try it outs in a function. I might still create other classes like a pet class and a rectangle class and an ingredient class or whatever we create, and now they'll all go in this file together, right? I know it's a little confusing, but the nice thing is when I get to the point and I want to run my code, you'll notice that my function appears here, so I can just call it and then do this. And then when I run the program, the main program body will run my little micro programs, which are really functions, right? And I'm just going to kind of do the grand reveal here. This is my example from last year, right? And these are all the try it outs that are in this module, and they're all here, right? And if I want to trigger one to run, I just uncomment it, and all the code is inside here already, right? So for example, I have an interface demo, and that's right up here at the top, right? And that's the only one that's going to run in here. But I have them all available, and if I want to try one or test one, it's all right there. So that's why it's kind of a clever way to do it. And so I'm trying to prepare you, right? And I'm trying to give you a mindset of ways you can work if you wish, right? Not that I would write real programs this way. And if you want, you can always add little comments or whatever, but I'm going to comment out whatever because it's irrelevant, right? But if I wanted to run it, okay, you guys want to prove that it'll run? Okay, there you go. Right. Very, very, very fun. Okay, back to the PowerPoint. All right, let's start talking about inheritance. So this is our first topic for the evening, and they start with the conceptual, right? So like we learned about the objects and classes with the blueprint and the actualization, or if you will, the instantiation of that blueprint as an object. A class is the blueprint. The object is the instantiation of the blueprint, right? So here's more terminology for you. And these words you already know, but now you're going to apply them in a different way. So we have this concept of, speaking about things in general and then speaking about things specifically, right? So generalization and specialization. And so let's kind of read through this example here and build up the concept. And it says, in the real world, there are general and specific things. Okay, that's true. Grasshoppers and bees are specific types of insects, and they have some common traits. So, for example, all insects have 6 legs, 3 body parts, and an exoskeleton, right? All insects have that. A bee has that, a grasshopper has that, an ant has that, right? For example. However, there's also special properties that each one of those insect has that is unique unto itself. So, for example, a grasshopper will jump, a bee will sting and make honey, right? And so there's kind of this terminology we start to throw in. And I'll be real frank, I don't think with is a thing in my head, but people do, right? And they call it inheritance is basically the is a relationship thing. So for example, a grasshopper is an insect, a rectangle is a shape, and a customer is a person. And if you're not picking up on the trend here, we're going from the specific to the general. So grasshopper is specific, an insect is general, rectangle specific, shape general, customer specific, person general, right? All right, so that's kind of the grand overview. Now, more terminology coming in now. When we use a class as the general definition of a type of thing, that is what we call the superclass, right? And it creates the general stuff that goes with that class. An alternate terminology is we do also call it the base class. We also call it the parent, et cetera, et cetera. There's a lot of different terminology we throw at it. The formal term, though, is superclass, right? That's the formal term, right? So in the case of the general, the insect class is a superclass, right? So when we want to create any insect, we can take all the things that all insects have in common and put them in the superclass as a blueprint for all insects. However, specific insects will have specific capabilities, right? So they'll say for simplicity, we'll use name and color, but in truth, it's the 3 body parts, the 6 legs, the exoskeleton. Okay, but in a sense, wait a second, if all of them have that, those are okay, well, those aren't really things we're going to change, right? Because all of them have that. Like cars have 4 wheels. Well, most cars have 4 wheels. But they're saying for simplicity, we'll just use name and color, right? Because every insect will have some sort of a name or a designation and some sort of a color, right? If grasshopper's green, bees are yellow and black, we assume, but they're more brown, I guess. All right. So there's also, aside from the superclass, which is the general, we also have the subclass, which is the specific, right? And so we can refer to those as they're pointing out here, subclasses or derived classes. So usually I hear programmers say superclass, subclass, but there is base class, derived class. That is a nomenclature that's used as well. So following through with the slide here, it says grasshopper and bee are subclasses basically of insect, right? They contain things that are specific to that type of an insect, right? So bees have a stinger, grasshoppers don't, right? Grasshoppers jump like crazy. Bees don't jump. I think they just fly around, right? They might walk, but they don't jump, right? Bees sting, grasshoppers don't. Bees make honey, grasshoppers don't. Grasshoppers are delicious, bees are not. I'm kidding, right? We don't know that property in particular, but there are unique qualities to each one of these, right? And then if you were really to look at each one of these, there's probably many kinds of bees. I know there are. I used to be a beekeeper for a while. And there's probably many kinds of grasshoppers as well. Right. So subclasses inherit from their superclass, as it says here. And, the diagram kind of shows it, right? So the bee and the grasshopper, the arrow's pointing up because they're getting insect features from the superclass, right? And since all insects have 6 legs, an exoskeleton, and 3 body parts, well, those are givens, right? But they're also named and they also have a color, right? So bees and grasshoppers have names and colors, right? And they will inherit that capability, but then we will add the things that are unique to them. So we'll make them specialized by focusing at what they have that's unique and not part of every insect, right? So it says subclasses also contain their own fields and methods. So for example, we learned that a class has its own data fields, right? We usually put those at the top. And then they have constructors and they have methods that perform actions, right? We learned about all those things. Well, subclasses have all that too, right? But they also share all the ones of the superclass. So if the insect class, superclass, has a name and a color, well, those are inherited by bee and grasshopper. And then bee and grasshopper each add their own data fields and methods that they, basically append to the insect stuff. That's how it works. So for example, it says a grasshopper has a jump method because they jump, right? Bee, an insect, do not. And bee has a sting method. Grasshopper doesn't, an insect doesn't. Not all insects sting. Some have like chompers and they bite you instead. Either way, hurts probably. All right. So how do we actually put this into play? Well, there's special syntax that we use when we're writing a code. So for example, if we have this insect class that we've created that contains name and color, and we want to inherit from that class, we use a colon and then the name of the superclass. So when I'm defining a grasshopper and I want it to inherit all the features of insect, I just add that to it. So whatever's in the insect class is now also part of the grasshopper. Not the other way around though, right? The insect does not inherit from the grasshopper, but the grasshopper inherits from the insect. Same is true with B. And then the point here is, they have whatever data fields they have, methods, whatever, but they do have methods that are unique, like grasshoppers jump and bees sting. All right, so that's their uniqueness. But to implement the insect superclass, we just do this.
Right? I have a quick question.
Yes, please.
Can you inherit from like more than one superclass? Like, would you just use another colon and then just keep adding on things? Like, if you had two.
Yeah, that's a really good question, because what you're talking about is kind of chaining them, but that's
Yeah.
not exactly how you would do it. So the way that you would engineer that is your superclass would also inherit from a different superclass.
Okay.
So it chains it, but that's a really good question, Teresa, right? Like, so I wouldn't say, colon insect, colon animal, that kind of thing.
Yeah.
Right.
Yeah.
But insect might inherit something from a higher superclass potentially. Okay. Right. And often when like you don't control the superclasses, you don't even know. That's even weirder, right? Because it does become a black box. But if you're writing all the code, then you do know. Now, here it says, to implement inheritance, nothing special needs to be done to insect to make it a superclass. It just is. So for example, I just define it just like I do here. I say public class insect. I give it a name, a color, a get set, probably has a constructor and some methods, whatever, right? But those are set, right? This is not inheriting from anything else, right? It just standalone. Nothing special we need to do here. It just is. An insect is an insect. Now, what if we do start adding some of the stuff in there? Okay, so this is kind of weird. Like, why do you use public and private? Here's an example. If I was going to be building a grasshopper that is inheriting from insect, and insects have a count of 6 legs, right? But this is set to private. This is not something I can access from Grasshopper because it's private. The public ones I can. So in other words, when I pull the features of insect into Grasshopper, these are the ones that come with, right? That at least I can control, right? So the kind of the point of this is, if I was to do like a console write line count leg, it wouldn't work, right? So it says private fields and methods aren't visible in the subclass. They exist in memory, but aren't directly accessible. So in the B class, you can't say lose leg, right? Even though that's a method in the insect class because it's private, right? And the same with count legs. This is a private data field that I cannot access. So if I was doing something with the grasshopper, I couldn't do this stuff. That's a little weird, right? Because the assumption I think is that you should be able to, that would be kind of the thought, but the private prohibits that. If you want them to be able to, well, you can do that. You just have to engineer it and set it to public, right? Right. Now, remember, we have this thing called a constructor too, which is a function in the class that has the same name as the class itself that allows us to build new objects, right? So interestingly, it says constructors are not inherited. So if I'm a bee, I can't inherit the constructor of insect, but I can create an insect directly, right? And then later turn it into a bee, but that's kind of a separate point. After all, it says their job is to create, and I think I should say, and, all right, let's fix it. And initialize an object. an insect constructor creates an insect object. So why would grasshopper want to only be an insect? You see kind of the weird logic of that? Because grasshoppers can jump. And if I become an insect, well, then I can't jump, necessarily. All right. So here it says, how do constructors work in inheritance? And okay, so here's kind of a little rule here. It says the superclasses constructor always executes first before the subclasses. So anything that's public in the insect will be included in my subclass. That's built first, and then the features of the subclass are added after. That's the procedural thing that happens in memory in this language. And I think in most languages it tends to work like that. Right. So they're doing a little example here, right? So we have a class called pet, general, very general, right? And then that has a constructor function called pet, right? So when I say, pet, new pet, whatever, this is the function that's called, right? And this one just does a write line. And then here we're creating a class called dog, which inherits from pet. Pet is the superclass. So this capability follows in this class, but this has its own constructor. Okay, so this is what's weird about this, right? So if I go ahead and construct a dog, in other words, I'm calling the dog constructor, what are we going to expect to happen? It's going to console write line, right? But here's what actually happens, right? So I say dog, Fido, new dog. Well, it constructs the pet first because that's the superclass, and it does the write line for it. Then it does the subclass constructor. So it runs both constructors. So that way, when you are building the data fields for an object, or and once again, if any of the methods that go with that object, if they're set to public in the superclass, that all comes in, right? And the reason that worked that way is because the constructor in the superclass is public. It kind of has to be, right? But that's the inheritance thing, right? And here we're doing write lines, which is really weird for a constructor. Usually you're populating data fields, in a constructor. That's most typical action. But you get the capabilities of the superclass and the subclass. Superclass created first, subclass created second, but they all travel with that dog named Fido, right? And Fido is not either one of these things. It is a real thing, well, real virtual thing in memory built from these two other things in memory, right? These are the blueprints. This is the instantiation. Okay, so there's this other little concept here of multiple inheritance. So it says in C# classes may only have one superclass. So, okay, so Teresa, this goes back to your question. So I can't do like, dog, pet, animal, or mammal, maybe something like that, right? Yeah, and who's to say that a pet has to be a mammal? That's a whole separate story, right? So, but I can have insect inherit from its own superclass, but you wouldn't see that from this level of construction. B would inherit insect. If insect inherits something else, that's defined in insect, right? But you can't chain them. So I can't have, well, a bee is an insect and an animal and whatever, So that's not possible. However, okay, so they're saying it can be many levels deep, and this is kind of like what I was just talking about. So bee and grasshopper can both inherit from insect, and then insect could inherit from animal. That works, right? So that's possible. And how deep can you go with that? Well, as deep as you can imagine, basically, or as deep as you can logically construct is really more what it is, right? Because when you are building objects that inherit from each other, there's kind of a logic to it, and that general to specific thing is really the logical guide. And maybe when you first get into doing this, you don't see that logic initially, but it does come with time, right? All right. And it says here, inheritance doesn't work in reverse. Okay, so it's a one-way relationship. Superclasses get nothing from the subclasses. So in other words, a superclass can't call the methods, can't use the data fields. So anything that's a instantiated insect can't access the methods of bee and grasshopper unless they are a bee or a grasshopper. Right. So you also can't choose to not call a superclass constructor. Okay, so this is weird. So if I'm calling on insect, its constructor will trigger, period. Right? It's got to build what it's got to build since we're inheriting it. And I can't opt out. Well, and think about this from a logical standpoint. Why would you if you're inheriting from it? The whole point is to do that. So if you want like silly analogies, it's like you can't choose to not have your parents be your parents. Too bad, that ship sailed. You know what I mean? You've got their DNA, whether you like it or not. You're inheriting their DNA, right? Now, which stuff you got from which parent, you don't know, right? But the fact is, once you were conceived, you were constructed, and your parents aren't going to inherit anything from you, but you are going to inherit from them. And I think that's not a bad analogy, right? So if you don't explicitly call a constructor, this is kind of interesting. C# will call the superclasses no arg constructor, right? That's what we call the default one. That's where no arguments go in and it just builds, right? What if the superclass doesn't have a no arg or default constructor? Ooh, well, then it will use whatever's there, right? Or will it? That's kind of a weird question. What if you wanted to call a constructor that has arguments? All right, this is all achievable, by the way. All right, so let's take a quick look at this. There's a keyword that we use to make that last question work, by the way. So, what we're really answering is, what if you wanted to call a constructor that has arguments from your superclass? That's really the question. So then we use what we call the base keyword. So this talks basically to the superclass, and we can use that keyword to basically grab the stuff in the superclass, both its constructors and any of the other methods, by the way, not just the constructors. And so here's kind of the example. Consider a person class that has a 2 arg constructor to initialize first and last name. So person is very general, right? And then customer is a lot more specific, right? It's a kind of person, but it's a kind of person that's giving me money to buy my products or services, whatever. It's customer, right? That has a 3 arg constructor, which is first, last name, and an account number. So if I'm going to instantiate a customer and I'm feeding it first name, last name, and account number, but the superclass only has accommodations for these 2 data fields, how does that work, right? Well, we have a way that we can kind of make that happen. So first of all, let's look at the person superclass, right? So the person superclass, first name, last name, gets set, right? And the constructor, which receives first and last name and stores them. Okay, pretty simple setup. And then we have the customer subclass, which inherits person. So it gets all of these features, right? And then I also have a separate data field for the account number, which is unique to the customer, right? Persons don't have account numbers. And then the default constructor for customer, right? First, last, and account number. All right. And it says, C# wants to call a superclass constructor here, but person only has this one, right? And so what it's telling you is this first and last name. You notice those data fields aren't in the customer class. They're back here, right? But I'm sending in the data, and this data will also travel up to the person class, but the person class has no way to handle it. So how do you fix it? Okay. All right. So let's talk about it first, and I'll show you the fix. All right. So a customer must call a person constructor. The person has doesn't have a no argument constructor, so C sharp can't call one. So we have to explicitly call the two argument constructor in the superclass. That's kind of really the answer. And then we have to pass those values of first and last name to it for it to work. And the way that we accomplish that is by using the base keywords. I want you to notice this little added on tidbit here. So we have our regular constructor that's named the same as the class with first and last name and account number, but this is handled locally. This is handled by our base class, right? Or our superclass. So we're sending, what this is saying is we're sending this off to the superclass so it can build the object correctly. Kind of weird, a little bit weird. Now, has anybody here ever learned Java programming? Have I asked this question before? Right. In Java, we have mechanisms that are similar to this, but in Java, if you don't do this, it just works. Okay, so that's kind of weird. And in Python, it also just works. So C Sharp's a little more particular with it. And it really lends to, execution stability, honestly, is what that does. All right, so we're at the point now where we're going to try to do some coding. And I think maybe before we dig into the coding, we should take a quick little break. We'll come back and we'll hit this first, try it out and see if we can build some of this stuff. So I'm going to go ahead and pause the recording here. All right, so now we are back from break and we are going to go ahead and try to code through what we have here on the screen. And let's read it first, right? So it says create a rectangle class or use your existing one. And I just happen to have that code handy. And what I'll do is as I'm building this stuff, you guys, I'm going to do a little bit of code sharing with you guys along the way. So I'm either going to drop it in the chat, and worst case scenario, I might even bring up my code share account. And I'll show you guys how to access that. It's kind of a cool little tool. It doesn't always work really well though, so I have some criticisms on it. So we'll see if we get to that point. But for now, I'll just try to do, from my examples here, pasted in the chat. The second part of this says, all right, actually, we should read the first part more completely. Use the existing one. It should have a length and width properties and a two-arg constructor that initializes the length and the width. Okay, that seems pretty simple. Create a cube class that is a subclass of rectangle, and it will have a height property, right? Add a three-arg constructor that initializes height, right? So it's like adding 3 dimensions, right, to the rectangle. Call the rectangle's constructor to initialize the length and the width. Okay, so I do have some of that code handy, and it's like my, just so you know, my example file is like 400 lines long, over 400 lines long. Shows you how much code there is to do in this chapter here. But I'm going to start out by doing a little preemptive things here, because I think maybe the best place to start is to create the thing that's going to run all this, right? So ultimately what we're really trying to do is build a cube, and I'm scrolling through hundreds of lines of code here on screen number 2. You guys aren't seeing it, but that's okay. And I'm looking for my rectangle class and my cube class. And the other thing that I'm also looking for is kind of my, and I'm just going to pull this over here so you guys can see what I'm looking at, rather than obscure it. There's no reason to. But I have like all these different little demos that I'm going to do. And what I'm trying to figure out is where I'm keeping my classes. Now, I want you to notice here the tool that I'm using. This is called Notepad++. It's just a very generic code editor. It's kind of like Visual Studio Code without as many bells and whistles, but it really kind of does as much. And it's just, I like it, whatever. But I'm noticing that my main program class, notice the indent level on it. It's one indent in from the namespace, right? And then my main method and all my sub methods are kind of one other level deep. When I get down to my class definitions, those are on the same level as the class at the top. So when you add this stuff in, and this is why I'm kind of giving this heads up, make sure that you're indenting it the right amount so the class is seen. Another option, of course, is you can take those class files and make them separate files, right? You can put them in a separate file and name them. So for example, if I wanted to take my rectangle class here, I could just take all this code, put it in its own file, save it as rectangle.cs, put it in the same folder over here in Solution Explorer. It will see it and operate just the same as me having it here, right? The reason I have it here is because I think this is easier to, for me at least, to do the example, right? All right, so let's start by me giving you the rectangle class in the chat so you guys don't have to type it all in. And then I'm going to do the same thing. I'm going to copy that rectangle class, and I want you to be mindful of where it goes, right? So I'm inside the namespace, but I'm outside the internal class or of the program. So I'm going to put it here, and that's where I'm going to paste it, right? So, right, a length and a width property with getters and setters, a toArg constructor that takes length and width and sets them to the internal properties of length and width. Notice everything is set to public. Constructors public and the two data fields because they need to be. All right. Now we're tasked to build a cube class, right? And this I'm going to kind of type in a little bit manually here, and you guys should do the same just to get the kind of the groove of how that feels as you're typing it. So I'm going to say public class. I'm going to call it cube. And then I'm going to put in a colon, which means I'm going to inherit from the superclass called rectangle. And notice how it finds it because it's in the same project, you know. And, you know, if this is helpful for you, you can put a little note here and say subclass, right? If that's helpful. And so, which inherits from the superclass named rectangle, right? If that helps you to put that all in there, except you should probably spell it correctly. Right, so that's what we're doing there. Then we're gonna put in curlies. Let's put our curly brackets in there. And we were told what stuff to add. So for example, we are going to add a public field that's a double, right? Why? Because the length and the width are. And I'm just trying to be consistent. And notice, boy, it's like really smart. This is insanely smart. It knows what I want to type. So yeah, I'm going to call it height with a get and a set. Sounds good to me. Are you guys noticing the underline that it dropped in there, right? And that's kind of the convention. I'm actually going to get rid of that, but it's recommended, you know, often to do that. You guys remember why the underline? It's a good thing it's not, we don't have a final exam, right?
Is it because of like the naming convention of like we might have another height that's in the public class itself?
Yeah, you know, Anthony, you're kind of tapping into the right stream of it, right? It's just kind of a way for us to know that it's an internal data field when we look at it, you know. All right, I'm not going to worry about that right now, but I am going to go to the constructor. The constructor that I'm going to build is this one, and I'm going to drop this in the chat. I just want to make sure you guys don't mistype it and we don't spend a bunch of time like troubleshooting it. But here's the constructor, right? Oh, and you see it's yelling at me here, so I must have deleted a curly bracket in the namespace. Oops, curly. There we go. All right, there it is, fixed. All right. So here's the two classes, superclass and subclass. You know, and I'm going to truncate this. But you see the approach here, right? So the approach is actually pretty simplistic. And the little extension of passing the 3arg constructor up to the superclass, well, we're passing two. We're passing the part to it to the base class that it needs in order to set the length and the width. So this is kind of like the realization of that concept, you know, if you will. All right, so now we should run some sort of a program here to try it out. So I'm trying to find my, maybe this isn't the most efficient way to do this. Because I'm like struggling to find my code on the other screen here. So I'm going to have to do a little find in my other program here. I almost feel like I should pause the video. I got so many screens going. It's crazy. Yeah, and really what I'm trying to do here is just do an instantiation. And so very, very simply, and I am sharing this with you. So, okay, here comes the cube thing if you didn't type it in. And then here comes the little function I'm going to write to run it. All right, so what I'm going to do with that function now is up here inside the program class, right? So you guys got to be sure that you're here, right? Please paste in that code. And I'm going to call it the first try it out. But if you want to just call it cube, that might be adequate, actually, now that I think about it. Because I don't think we do another cube thing. Yeah, just cube is fine. Let's just call it cube. And then up here, we can get rid of whatever. By the way, if you got a whatever in yours, get rid of it. And then here, I'm just going to say cube. And then what is this going to accomplish? Well, let's think about this. I'm instantiating a new cube. I'm putting in 3 values. What are those 3 values? Well, it's length, width, and height in that order, right? So we're going to output those things. And you know what? Maybe height should come last. Maybe we put it down here. But I think you get the general lay of the land here, right? We are instantiating the object, and then when we do the write line, right, here's what's happening. We send this in to create a new cube. It's received here. The height is handled locally, but the length and the width get shot up to the superclass to create those properties. However, when I've created the cube inherits from rectangle, and because all those fields are public, right, I can reach into that and I can output all of those things. So let's go ahead and run this and just prove that it works. Right. And so there we have length, width, and height. Length, width, and height. They went in that order. This was set in the subclass. These 2 were set in the superclass. All right. So Anthony, you're getting an error. And you know what? Let's take a really quick look at that. I'm going to pause the. All right. So hopefully that worked for everybody. And if not, let me know and we can try to solve it, of course. But let's move on here. And then our next topic here is overriding. Overriding is kind of an important topic for a few different reasons. And let's kind of dig into this so I can explain, I guess, first what it is, right? And so you understand. So normally when we say, we do an override or overriding methods, this is, kind of like finicky little stuff. So make sure you kind of latch onto this. It says a subclass can have a method with the same signature as a superclass method. Okay, so this, in other words, the subclass might have, a method called a specific thing. So let's think about the maybe the insect example is a good one, where all the insects can walk, right? Right. So the subclass has a method called walk, but so does the superclass. So if I call the method walk, the subclass will be the one that operates, right? So the subclass method is more specific to the object, therefore it overrides the superclass method, and that's the one that works. So since, for example, a pet class as a speak method that writes hello. A dog class inherits from pet and overrides speak to write woof, right? So like if I don't tell the dog to speak, okay, fine, it won't speak. But it will do its own, not the superclass version. That's kind of the point. So once again, here's the example. Pet is the superclass, and it has a speak method built in, right? And it works for all pets. So apparently all pets can say hello if they don't have their own speak method that does their own sound, right? So now notice the keyword virtual in the mix here, right? So that allows this method to be overridden by the subclass, but virtual has to be there, right? Otherwise, this one will take precedence. So virtual indicates the method may be overridden. Dog is the subclass, right? Its speak method is specific for dogs. So all dogs bark, right? Override indicates that the method is overriding the superclass method. So once again, we're going to declare it here. So the point of it is you need to know what's going on and you need to engineer it. That's really kind of the grander point. So hopefully that's fairly clear. So it says C# always chooses the lowest implementation. The subclass method will run, the superclass method will not if I just do this, right? So this is kind of strange, right? You know, so once again, when I compare to other languages do not operate exactly like this. So C# is somewhat unique in this regard. So virtual and override help this situation function correctly. There's also this other terminology that we do throw around with objects and classes, and not to confuse the two. So this is what this slide is about. There is this thing called overriding, but there's also this thing called overloading, right? So overloading, the difference is when you have two methods that have the same name, but they have different size parameter lists. And we see this with constructors. So for example, we'll have a no-arg constructor or a 2-arg constructor or a 10-arg constructor. They can all be named the same thing and they adapt automatically. So that process is called overloading. Now, in the overload example they're showing here, they have two methods that add things. One deals with a list of integers and the other one deals with an array of integers. And you guys remember what the difference is? Like an array of integers, like you can't change the size of it, it is what it is. But a list, you can dynamically add and remove components, right? So what this is saying is that a list can be any size, and this int array is, you know, set. And so it's basically a different parameter list going in. So this would be overloading. In a more traditional example, I might have like 3 things going into add and 2 things going into add. And that's called overloading, different than overriding. All right. So, okay, so overriding is when 2 methods in an inheritance relationship have the same signature, right? So that's the override, right? And we have the keywords that go with virtual and override to help us remember that. The overloading is when you have the 2 methods that are usually in the same object, but they have different parameter lists. So those are kind of weird, right? But those are things that we do. We'll play with those a little bit as we do examples, by the way. And I think I might have an example of an override here. Let me just take a really quick look at it. I'm going to pause the video for a sec. All right, let's move on to the next little topic here, which is to use the ToString method, right? And this is kind of an interesting little thing because it says the root of every inheritance tree is the system object class. So in other words, no matter what class we create, no matter what it inherits from, given the fact that we've created it, the language itself has a master class for all objects, right? And we don't see it, we don't have to declare it, but ultimately every class draws from that object, right? So that's kind of like the superclass for all objects that are built off of classes, right? Right. So every class is ultimately an object. So it says if a superclass contains what subclasses have in common, what can all classes in C# language possibly have in common? That's a really good question. What is the commonality? So if you start asking yourself that question, right? So here's what they have in common. Every object can generate a string representation of itself, right? And usually we do this by using this method that's built in to the superclass, the topmost one, right? That has a ToString method, and every object has a ToString method automatically included with it, right? This is kind of the weird part of this. So for example, when the ToString method is called automatically when you print an object. So if I create a new customer, right, Bruce Wayne and his account number, and then I right line the customer, I can do that. I can take an object and right line it. Yep, I can do that. Right. Look at what the output of that is. This is what it is. So what is it? How is it displaying that thing? Well, what it's doing is it's reading basically the master class. So like apparently the master class is module 7, and the name of the class that we created it from was customer, and it's right lining it. It's showing us what its structure is basically, right? So when we do the ToString method, it shows us the whole chain of inheritance that it's drawing from. So module 7, of course, is probably the namespace or the program name, right? And then this is the class structure within it. Right? When I do a right line here and I just output a piece of text and the object, it will do the same thing. But it is pulling from that hierarchy to make that happen. All right. We can also call it explicitly. So like if we don't include ToString, that's actually what's going on. But we can also try to manually invoke it by saying ToString. So all objects have this built in. And the reason really is for programmers, right? So we can see like what the heck's going on with this object. So we can invoke it that way too, by explicitly saying ToString on any object. We still get the same result, right? So what this is telling you is when I do this, I'm actually calling that. This just obscures it. That's really the difference. Output is exactly identical. All right. So, and it says here, and I agree, the default behavior of ToString is not very useful, right? What it does show you though, okay, and this is kind of important, is that the object exists. That's what it shows you, right? And its hierarchy. So we can actually write our own ToString methods that override the original. And then by doing that, of course, C# uses our version instead of the one that's built into the master class of object for the whole C# language, right? So as it says here, this is the header for the original ToString method, right? Virtual means the method can be overridden. So in the object class with the language, virtual is included in the definition of ToString. We don't see it, but it's there, right? So therefore, when we create our customer class and we want to override it, if we create a ToString method, we have to include the keyword override to allow for that to happen, right? It says, be careful. The signature must match the original exactly. So an example ToString in the customer class, right? So they have to be exactly the same. So in other words, you can't name it like, well, I'm going to abbreviate string and just do str. No, you can't do that. That's not going to override, right? It's got to be named exactly that for it to work. So the subclass override of ToString has to be exactly named the same as the superclass version. Here it says, basically it says a ToString method with an object initializer. And I want you to take a look once again at this little, I call that a lambda expression, that when you do that, like equals with a greater than after. So if I want to, instead of doing this, where I just use regular curly brackets, I can also shortcut it and do this. Notice the string interpolation, right? So whatever we want it to really return, we can define that. So we can actually pull pieces of information out of that object and tell it what to output. So when somebody just types the object name in and says console write line, this is what will come out. Why? Because it's built into the subclass, right? And I like this approach a lot. Here it's on 2 lines, but you can put it all in 1 line. And I really like that approach. It's very, very efficient. Now, okay, so since I've defined this or this, either one, right? That has the account number, last name, first name, right? Now when I output the object, now it's going to output what we want it to, as opposed to like the project hierarchy or whatever of the object, which is irrelevant to us really. So this information in the output becomes a lot more useful. And this is a common programming technique that people do, by the way. All right. So now we have some try it outs. And I think that what I'm going to do here is I'm going to build this, right? And we'll take our time doing it so I can show you how it works. But I also want to go back and show you the little override pieces, maybe with some other objects. So we'll see kind of as we go along. All right, let's read the instructions and then start to try to code this. It says create a class named television with the following properties: a Boolean for whether it is on or off, a double for the current channel, and a string for the manufacturer. Create a ToString method that returns a string like the Sony television is tuned to channel 4.1. It is currently on. So it's like reading its own properties, basically. And then in a driver class, create and write some television objects to test your ToString method. All right. And, so in the process of doing this, really what is happening is we are going to be doing overrides here. So first, we need to build a television class. And so I'm going to do that first. So let me come over here to my code, and I'm going to first set up a class structure. And I think the way that I'm going to do this, and I recommend that you do the same, is every time I add a new method to run a program, that's going to go at the top. So I'm going to put that next one here. And every time I add a new class, it's going to go at the top of the class. It's just so I don't have to search as far like I'm doing on my other screen, basically, where my solutions sit. So the first thing I'm going to do is create a public class television. Okay, curlies, right? They want us to create some fields. Okay. So I'm going to drop the first 2 in. And if you guys want to save your typing, I'm going to copy paste this stuff. Okay. So I have a Boolean created called is on. And whenever you create a Boolean, this is kind of a tip, by the way, is name it so that it makes sense that when the true false value sits with it, so it's like, is the TV on? True. Okay, that makes sense. Is on? True. You see what I mean? So often with Booleans, you name them kind of like questions, right? The other one was the current channel. That's a double. We got getters and setters for both. They're both public. All right. The other one is the manufacturer. And what I did with this one, and all right, I just put a get in there so I can only get the information. And then I added this little note to it last time. So I'll let you take a look at the little note. It says removing the set means that you can only set it in the constructor. So only when we build the TV set can we declare what brand it is, like Samsung or Sony or something like that. Afterwards, it is what it is. You're not going to be, hey, I got a Samsung TV. I think I'm going to set a new name or new brand for it, right? And you're done. No, you can't do that, right? So some of this is like logic driven. Now, can I change whether the TV is on or off? Sure. Can I change the channel on the TV? I sure hope so. Right? See the logic? Can I change what brand my television is? Only by throwing it away and buying a new one, right? In which case, I'm constructing a new one from the object. All right. So those are the data fields. All right. So here comes that code in the chat if you don't want to type it. All right, now I'm going to add some methods. Okay. Okay. And we were given some instructions. So one, I think, instruction was to build a constructor, right? So here's going to be my constructor. And once again, in the chat, and I'm just dropping all the code in just to save a little bit of time here. Normally I would code it by hand, but we have a method, constructor function, or whatever you want to call it, constructor method, named the same as the class. I'm sending in the current channel and the manufacturer. Okay, I'm not sending in whether the TV is on or off. So when I create a TV, I'm not like turning it on when I'm creating it. I'm creating it, then I plug it into a wall and then turn it on. So when I build a TV, all I need to do is set the current channel, probably like channel 1, right? Or 2, if that's the first channel on the TV, and then the manufacturer. Notice though that the is on is being triggered to false right when I make it, right? Because you don't want to ship a TV that's on, whatever. Enough logic, all right? That's kind of the thought. Right. Then I'm going to create an override method, right, called ToString. Notice the use of the keyword override, because in the master object class, there's a one that's got virtual on it called ToString that we're overriding. We don't see it, but it's there, right? So we're creating one by the same name. And then we just have a return statement that via string interpolation is including the manufacturer of the television, it's what channel it's tuned to, and is it on? And I want you to notice this is kind of clever here. And I'm going to try to expand my width here just so you can see this little statement. But inside this little piece of string interpolation, you guys noticing the if statement, right? This is a ternary if, right? If you guys remember that from like module 1 or 2. And what we're checking is on. So is the TV on? It's going to be true or false. So if true, we'll say on. If false, we'll say off. This is the implied if, this is the implied else. This is one of those scenarios where it's a super simple little statement, often used with Booleans, checking for true and false to provide one value or the other. Works beautiful in output, right? So it's dynamically checking to see if the TV is on or off. All right, so this is our class structure, right? And you guys are like, where's the paste? There it is. Right, you're waiting for it so you don't have to type it, so you can try it. And then we are going to need a driver class for this. So I do have one created. So here's the one that I built last time, and I'm just going to come up here to the top. So I'm going to show you how I'm going to do this. So below my main method, I will paste that in. It's called television. If I want to run that method, I'm going to type its name with the parentheses that we'll call it. I'm going to blot out the cube because I'm done with that one for now. And now when I run my program, it will run this function or method that will, well, let's see what it does. It's going to create one new television. We're setting it to channel 4.1. So if you're wondering why a double for a channel, right? For digital TVs, you know, they don't just have channel 1, 2, 3, 4, 5. That, you know, and if you get digital over-air broadcast, some people don't even watch TV anymore, but if you get digital over-air broadcasts, like channel 4's got more than one channel, they have sub channels and they go dot, right? So like over-air broadcast works that way. So we're setting it to channel 4.1, and the first TV is a Sony, right? Then we're gonna console write line TV. It's going to use the ToString method, right? And then we're going to flip the TV on, change the channel, and then check its status again. Then we're going to do the same thing with the Samsung TV. We're going to put it to channel 1001.5, set it to Samsung. We're going to output it. Notice this time we will use the ToString method implicitly. So we're going to call it by name. This is calling it anyhow, even if you don't include it. And then once again, we're going to turn it on, change the channel, and put out the information again. So let's run it. And I'll put the output screen right next to it. Right. So we create our TV. So the Sony television is tuned to channel 4.1. It is off. Then we turn it on, change the channel. Now the Sony television is tuned to channel 5.1. It is on. Right. Then we do the Samsung TV, same thing. Turn it on, change the channel. And you can see that we're able to flip those properties and manipulate them. More importantly, we have done an override of the method ToString, which exists in the master superclass of object, right? We did it both the implied way or the explicit way. And I think I said that backwards before. So this is the implied ToString when we just call the object, right? This is the specific ToString. It is not pulling from the object class. All of them are pulling from our override method that we explicitly defined. All right. Everybody get that to work? All cool? Remember, it's not an exercise. You're not turning it in. Really, the concepts are the important part here. Let's keep pressing forward with the slideshow here. Let's try to make some more progress. We're doing pretty good on time so far. We're going to try to get through at least this next section here. All right. We are now going to talk about the concept of static, right? And this is one of these really weird keywords that we've already been using and we haven't really talked about it, right? You know, so now we're going to learn like what it means. So for example, like when I wrote the functions here, I made these static functions. In fact, the main method is static. What does the word static mean? Is that like when you rub your feet on the carpet and you get a shock? No, that's static electricity, but yeah, I guess that's static too. But generally what the word static means is not to change. That's what it means, right? All right, so let's kind of talk through the logic of this. So it says every instance of a class, each object gets its own copy. So once again, we have the blueprint, and every time we build a house from that blueprint, every house we build is a unique house. It's its own house, right? One rectangle can have a length of 5 and a width of 10, and another rectangle can have a length of 7 and a width of 3, right? They are unique rectangles, clearly. I mean, look, they're different, right? All right. And then we have instance methods, which operate on the instances of the class. So we have these methods that we build. So for example, if you remember, we did the rectangle thing and we were getting the area, right? And that's an instance method. And it says returns the area of one rectangle. Which rectangle? The one we're working with, you know? So this one has its own get area, and this one has its own get area, and that function travels with it, just like its properties of length and width travel with it. The get area travels with it too. Okay, so now we'll get to this static concept. So static members basically belong to the class itself, not to instances. Okay, so for example, all instances share one copy. You don't need an instance of the class to access the static members. Okay, so their point here is like, I think they're trying to make the point that there's a count, right, of one. How many rectangles do we have? One. Okay, well, that's not changing because it's just one rectangle. Okay. Now, I don't think a great example. Right. So when we declare fields with the static keyword, right, fields declared with the static keyword belong to the class. Only ever one copy in memory. That's kind of a weird wording, regardless of the number of objects. So for example, if I'm creating an object from my class and I have this field set like this, it's private, it's static, it's an integer, and we're setting a count, and I set that to 0, that's only initialized once. When I create other objects from that, that count is shared amongst those objects. The first time they are referenced, it is created, basically. All right. There's also static methods. We have static fields that are built into objects, and we can have static methods that are built into objects. And static methods can be used without an instance of the class. Okay, that's kind of weird. All right, so here's the example. A lot of times when we're using the math libraries, we'll call in and we'll use syntax just like this. We'll say math.min xy, right? And I don't need to use the rest of the class called math, because this syntax here is telling us there is a class called math that has a method called min. I don't care about what's in math. It probably does a gazillion things, right? It's math, right? All I care about is that one method. So I don't need to create I don't need to instantiate math to use the min method. That's the point. I can just use it, right? And I think that's really cool, right? So I can reach into a different object that has a capability and call its capability in and utilize it in my program. That's what the math thing is. And it says here, you can call static methods using the class name. So for example, you know, this is doing a right line. What is it right lining? Well, I'm right lining this, but that is being generated by this, right? And so really, you know, we just call it by name, utilize it, and then it's available to us, even though we're not creating a whole object. All right. Here's a little exercise we're going to do now, and this is something we are going to code through. And let's read through the slides, and then we'll do the try it out. Right. It says, let's make an employee class. Fields for name, salary, both passed into the constructor. So this is kind of like our pseudocode, sort of, right? A field for employee ID, which is not passed into the constructor. Each employee that is hired gets a successively higher ID. So like your employee 1, your employee 2, your employee 3, etc. Right? All right. So that's kind of the basic lay of the land there. And then we're going to increment the employee ID. All right. So we're going to add a static int field called next employee ID. And notice the underscore. It's going to be initialized to 1 because the first employee will get, that will be their ID number is 1. The next one that's instantiated will be 2, right? So in the constructor, we're going to assign this as the employee's ID, and then we're going to increment it every time. So in other words, we're going to assign the value of what it currently is, and then we're going to increment it for next use. And that's going to be done in the constructor. You guys seeing all the detail here, right? So this is giving us a step-by-step of how to build it. And yes, it's a little more complicated than some of our basic programs so far. All right. We're also going to be incrementing the employee ID. It says create a getter that returns the static field, not a setter. You catching that part too? And that's kind of like the thing I did with the TV set. It's like, hey, we built the TV. It's not changing brands now, it's built, right? Same thing is true with your ID number. You got an ID number, what, you need another one? You know, I'm just trying to be a little snarky with it, but you know, I'm just giving you the thought process, right? So in a driver class, write a loop that creates a bunch of employee objects, right? Telling us what to do. Can static methods access the instance fields and vice versa? So we'll ask that question. We'll come back. We're going to go back through all these as we're doing it, right? And there are some limitations though. So check what this says. So static methods cannot access instance fields or instance methods. Okay, so here's kind of the definition of employee. And so we are given some of the code to start with. You guys catching that, right? And then down here, right, when we are trying to return, what are we trying to return here? Employee ID and name. Okay, well, employee ID. Okay, static methods cannot access instance fields or instance methods because this is declared as static. We cannot access the instance fields or instance methods. So I can't do this. I can't reach up here and grab this information because this is set to static. Okay. This is kind of an interesting thought. So now your question should be, why on earth do I have these then? The static methods really become tools for us to allow external factors to utilize that code. It's not about the stuff that's inside, it's about the requests from outside, is really what that is, right? Okay, so you have to engineer your way around that to make that happen though. All right. All right, so and you know what? I'm thinking here, maybe we can do this employee thing kind of as they describe. So I'm gonna get my static demo going here. And we'll start by creating employees. So what I'm going to do here, I'm going to give you this in chunks, right? And I'm going to paste them in the same chunks that I'm giving you. There's the first chunk in the chat. And so what I'm going to do is first create a class for employees. So we're going to do those steps that we just saw, all right? So first I'm creating a class for employee, right? There's the employee ID, right? That's just a get. This will be auto-generated, remember, right? And then we have a string, a salary, and then next employee ID. Remember, that one's set to static, right? Then we need a constructor function. So here comes the constructor. I'm dropping that in. And if you're not comfortable with the error messages you might be getting right now, you can always throw a curly bracket here, and then at least the class is complete. Right, so there's mine so far. Notice the constructor, and we're following what the slide said, right? We're sending in the name and the salary. We're populating the fields that we can. And then the employee ID is grabbing the next employee ID. Notice the plus plus. And remember what plus plus does and how it works? It's a post incrementer. So it will grab the employee ID first and then increment, right, afterwards. Right. Then we're also going to have a static method. And I wasn't kind, right? I did not put this in the chat. There's the constructor. And then we're going to add a static method. So I'll drop that in the chat first so I don't forget. And then here is that static method. And all this does is returns the next employee ID. And I want you to notice how it's named as well. And this is not something, right, that necessarily has, that we're going to use internally. We're not going to use this to modify any information. This is kind of the point, right? We're only going to use it to extract information. And I'll show you how that works. And because we're kind of in this mode of learning about the ToString method as well, I've also created a ToString override, right? That looks like this. And I don't know if you guys remember that alternate way to do it, where you do the equal sign greater than, and then you get rid of your curly brackets and your return statement. And you just go directly to the output. So you can do it like that too. I'm going to try that approach in your chat. All right, so now we have the classes built. Has all the capabilities we talked about. It's got a static public method, and it has a private static field. Now I'm going to create a little program. And last time I called it static demo. Maybe I should call it the same thing again. So up here, actually, let's do something kind of weird. All right. First thing I'm going to do is I'm going to comment out television. So we're not going to use that right now. And I'm going to create a call to a function. This is kind of weird, called static demo that I don't have. Okay. It's underlining red. This is kind of weird. So this is kind of like a programmer shortcut, by the way. So like a little professional tip, right? So sometimes programmers, instead of like writing the method or function first. Sometimes they write the name of it, where it's called from, and then they use the automatic fixes, right? And I'm going to go here, right? So we use a little thing, and notice it knows that it doesn't exist. So it's saying, hey, do you want me to write a method for you? And I'm going to say yes. So I let it write the method. Isn't that cool? Sweet, right? I like that a lot. All right. So it is throwing this little exception handler in there we don't need, but at least I didn't have to code this. And this is fine. It did set it to private, which I normally, wouldn't do in this situation. So you want to leave that there, you can leave it. I'm going to remove it, whatever. Right. We'll have no impact and functionality. But ultimately, what I want you to do is what I'm going to do, which is to instantiate a bunch of employee objects. And don't panic, I will put this in the chat. There it is. And so I'm going to create employee 1, 2, 3, and 4. I'm giving them all names, like the names. Right. It wasn't my clever idea, by the way. I stole this from somebody else. And then this is their salary, whatever that means, right? We are going to output their information, and then we're going to do a little write line that says the next available ID, which is basically pulling it back from the static method. So I want you to notice how that's being called. We're using the fully qualified object, right? It's like we do the math library. We're not referring to EM1 to get the next employee ID, because if I used EM1 here, notice how it's underlining red. This is kind of the point of these slides, right? So I'm using the generic version of the class because it's a static method, and then I can call that method and it just tells me what the next ID number is going to be. That's the big takeaway here with static, folks. All right, so let me run it. Oh, and it says there's build errors. Oh, thanks. All right, I don't know what the build errors were. There's one error in there somewhere. Oh, I think I know what it is. Okay, I think it's a curly bracket thing. It still ran, right? Oh, it's still running the television. Okay, so it's running the last version. So this is not correct. So let's go to that. See the red mark on the sidebar there? We're going right to it. And what is it? We are missing a curly bracket somewhere is what it's telling us. So that all looks good. My public class employee, did I like delete one by mistake? I think I did. So I think okay, so the namespace is not complete. I am missing your curly bracket. Now I just got to figure out where. All right, so this is kind of fun to put in a video. But how do I know that is because when I'm collapsing these things here, like the namespace should collapse everything, but it's not doing it. So what that should tell me is that it's broken right above television. Not that television, this television. Oh, yeah, extra curly bracket right there. Right, because I changed the format of this. Okay, notice the red underline is gone. Now we're going to run again. I think we're good now. All right. And what I do want to do here in the code is I do want to put all the run information here so you can see the objects being created, right? Mario with a salary of 2025, right? Notice how they're numbered, right? What's the number? That's their employee ID number. All right, hint, 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 right? So some of this stuff might be used on the final project or on the labs, right? So some of this stuff is useful. It shows me the next ID numbers too. So it shows me that the class structure here, wherever employee is, right? That's private. When I build my employee, whenever I construct them, this can grab it, right? It increments it, but it increments it after the action is performed. This static method only allows me to see this value, right? So, and then I can output it and see it all, but the proof is that it works, right? And what it's actually doing. And I think this is really kind of a nice little demo, especially when you think about that concept, right? We're not calling the object to get this method. We're calling the class itself. All right, let's move on. It's pushing on 9 o'clock here, and I think we might be at maybe a good stopping point here. Maybe now is a good stopping point, and then when we come back, we can do this, try it out. So let's do a 5-minute break. Then we'll do this, try it out. We'll try to get as far as we can here tonight. So 5-minute break, folks. Let's see you in 5 minutes. All right, so we're gonna do this, try it out now that we're back from break. And I was looking at my previous example. And what I did is, instead of using the rectangle class that I already have, right? So there's this rectangle class. I'm going to copy this one and then add some capabilities to it. And really, in order to make this go as fast as possible, once again, I'm just going to give you the whole class that I'm creating, because I just think that's just a little more efficient, basically. So let's find a spot in our code where we can add it. And I think what I'm going to do is I'm going to keep my pattern going where all my new classes will be added to the top, right? So I'll put it here. I am going to call this rectangle 2. And don't worry, I will paste the code to you. And we are given some directives here, so it's probably important to read those. It says, using the rectangle class, create a static int named count that starts at 0, and create a method named getCount that returns the value of count. So this is kind of like what we just did, right? And so we'll need that field. So here's the data fields, right? So this is kind of like what you had before. I'm just going to give you this, so don't type. There you go. And then we need our constructor function, which is, I think, what they're pointing out next. And the rectangle constructor increment the count. So that's what we're going to do. So here is that code. So I'm going to add that method here. And once again, you notice all little red marks on the sideline there. I'm going to just fix that really quickly by just putting in a curly bracket here, just so that's complete. So this is our constructor. We're sending in length and width, but we're also increasing the count each time as we're doing it, right? And notice that designation of private was the other little thing that we didn't talk about last time. That was the underscore thing. We know it's private that way. All right. We're also going to have, if you read this here, in the main method, create a few rectangle objects, right? Use the getCount method to print out how many have been created. So apparently we're going to do the overrides, because I have an override version of this. I see. Okay. So let's create a method called getCount that returns the value of count. So that's pretty easy. So we'll do that like this. Right. All right. So this, right, this one doesn't need to be static, right? So just the int needs to be static. Now we should go ahead and create a few rectangle objects. All right, so let's try to do that. And I am going to code that, but I have some code already prepared so that we can save the time in coding that. So Find it on screen number 2. Right, so I'm going to give you all this code all at once. I'm hoping it fits in the chat. Looks like it fits. So you have the whole thing. So with this code, I'm going to go back up to the top of my program. And I'm just going to paste it in. Right. And it does want me to do, oh, okay, I see. So we have, okay, so this is looking for a default constructor, which I didn't create. So I was wondering why I had that. So I'm going to add that in. So we're going to go back down to the bottom, and I apologize for all the bouncing around, but let's create a default constructor. This is the code for the default constructor. I'm going to go back down to that class structure, and right below the 2-argument constructor, we're going to add a no-arg constructor. So if they don't declare length and width, it's automatically set to 1. That's the only difference, right? Length and width are set to 1. So now if we go back up, look at our rectangle demo. We are going to create a rectangle, and then we're going to output the get count. So we'll see what the output is for get count. Now that one, we can refer to the object to do that, right? This one, we're sending in 2 arguments, and then we'll get the count. All right. Now, I don't think we've been told to do this yet, so this must be coming later. All right. So that other code, this is for a later example. So if you want to comment that out, I would say comment that out. No. And actually, all the rest of that code should be commented out. And what I prefer to do is, if you're doing that method of commenting, just do that. So this is for a later example. We have it pre-built, when we go back to it. But our job right now is just to basically build the rectangles and get the count. So let's run it. See if it works. Is it going to work? No, it's still doing the Mario salary thing because I never called it. So let that be a lesson to you as well. So we added a new method here, so we want to call it. So this is what is this called? Rectangle demo. Sometimes it's better to do it from scratch. We're just going to call it to run. Now it should run. All right. So what's the count? 1 and 2. Is it returning it correctly? Absolutely. If we want to look at like other information, we could write a ToString method if we wish. Later on, it looks like we're going to put it in a list, but that's going to come later. But you have the code for it already. All right. Next thing that we're going to do is move on in the material here so we can talk a little bit about this concept, which is aggregation. All right. So not one of those fancy words, but basically, when you aggregate something, we're taking a bunch of little things and putting them together to make it one bigger thing, right? And so that therefore a whole made of parts. And programs, computer programs are totally like that, by the way, right? Like you do all this coding and building, and you're really always building all these little pieces, and then you string them all together to get them to do the magic, that they're doing, or what seems like magic, right? So when the other way you look at it is when one object contains another object. So this is kind of a thing that happens a lot in programming, because often we create all these classes, then we create a bunch of objects. Some of them draw from superclasses and super classes, right? And so really, like an object is contained inside of another one, just kind of the reality of how we operate in the real world, right? And that's the point of the last bullet, is it mimics real life. So like, for example, a house is an object, but a house contains doors and windows and walls and plumbing and furniture, and all those things are objects, and all of them have their own information and capabilities and data that go with them, right? And so it's not really that weird of a concept to have an object inside of an object, right? A piece of furniture inside of a house is a great one. Or for example, a course contains an instructor a textbook, and students. You guys are objects too, right? You have your own properties, first name, last name, student ID number, classes you're taking, the grades you've earned. All those are, things that pertain to you, and you're part of a course, and the course is part of a school. They're all objects. The keywords that we use when we do aggregation is, instead of it's a has a relationship. So for example, a course has a or an instructor, or a course has a textbook. Those are objects that are part of the course. So that's kind of a good way to think of it. All right. So here it says create a company class that contains 2 employees, a president and a vice president. The company should also have a string for the company name and an int for the year founded. So now we're going to do another little program build here. And we have some of this stuff already built, right? So we already have an employee, right? And we have to designate their role, apparently, right? A president, vice president. And then the company should also have these other features. So now if you're kind of reading through the lines here a little bit, here's where we're going with this. What we've done before is, if I take a superclass and I want to extend its features, I use the colon, like a dog and a pet. Now we're going to create a class that, instead of extends a superclass, will contain a complete object. So for example, the company will contain 2 employee objects, one named president and one named vice president. All right, so I don't know if you guys feel where I'm going with this, but I'm going to show you. All right. So down in the lower section of your program, and you know what we could do here, and this would probably be handy for some of you, including myself, right, is I'm going to create a little divider here, and I know back to ASCII art, and I'm going to say class definitions down here or something like that, right? Meaning that everything below here is basically a class definition, and then all my functions will go up here. Like little programs. I'm making fun of it, but right, that's basically what it is. And what I'm really doing is I'm just kind of putting little dividers in here so I can find stuff faster. But we already have an employee class. So if you guys remember how this works, we have this class definition for employee, and instead of creating new objects of this, we're going to include those objects inside the company class. So what I'm going to do is, and I'm not going to put this by rectangle, I guess I'm going to put it right by employee. So I'm going to create a public class company, spelled correctly, right, with curly brackets. All right, so you can type that part in yourself. Then we're going to create a couple of data fields, right, because it asked us to. So the company is going to have a name, and it's going to have the year founded, both with getters and setters. Then here's the new wrinkle, right? We can also add employees as objects as well, as kind of like a data field in this object. This is kind of a weird thought. So I'm going to create an employee, which is going to pull from this class, right? So I'm not extending or anything like that. I'm just creating a new employee right here, public employee president. Now this really, if you think of the concept that a class or a blueprint, right, can also become kind of your own data type. And that's how we're using it here, right? So we're using employee kind of as a data type as the president, and we can get and set the president or the vice president, right? All right. If you guys want to save the typing in the chat. Right. Then we need to build a constructor. All right, that's going to set all this stuff. All right, so follow with me here because this is kind of weird, sort of. All right, first thing I'm going to do is, well, you know what? I'll just give you all the code at once. Maybe it's just easier to talk about the code than type it out by hand. But I am going to have a constructor that's going to take the name, that's the name of the company, the year it was founded, a string with the president's name, a double with the president's salary, a string with the VP's name, and a double with the VP's salary. Why do I need to send these in? The answer is because when I construct an employee, I need their name and their salary. So when I'm constructing a new company, I'm sending in the president's name, salary, VP's name, and their salary as part of the constructor. And these are just regular data fields. We just set them like variables, no big deal. But now here we're constructing new objects. Here's the construction of the objects with the constructor data thrown in. And so when I build these two objects, they will travel with the company. Isn't that really cool? That is really cool, I think. I know. For a geek, it's cool. Okay. Right, but this is the whole thing. You guys have that constructor function. Now we need to write some code to test that. All right. So this is going to be called the company demo. So I'm going to do the backwards approach up here now. So I'm way back up to the main method. I'm commenting out my rectangle demo. And now I'm going to build a company demo, right? It's going to recognize it's not there. I'm going to use the little auto generation of the method. There it is. I'm going to get rid of that. I need to move my ASCII art up so it's in the right place. We'll put it up here. Right, there we go. And then we'll start the code. I am going to remove the private thing just in case we want to call it externally. I don't think we will, but just in case. All right. So now for the company demo, I'm going to give you guys the whole thing in the chat there. You don't have to type any of it. But I'm just very simply going to create some objects. So I'm going to create a new company, and I'll put this all on one line just so you guys can see it. I already have my solution explorers like collapsed all the way down. So this is really what the call is. So I'm creating a company called company, and I'm feeding into it. Well, what's it called? Toy Factory, founded in 1800. Santa Claus is the president. He makes 100K a year. Mrs. Claus is the VP. She makes 100K a year too, right? So it's kind of a little bit seasonal as well, since we're going into Christmas. And then we're going to right line the company and pull back the president and the vice president information, right? We don't have a ToString method, but what's this going to output? Let's see what it outputs. I think this will be interesting. Right, so let's run it. And then you tell me, is this what you expected to see? Why is it giving us the name of the president and the salary and the dollar amounts? Okay, so here's the why. Because that comes from the employee objects ToString method that travels all the way through the company. So we built this company object, we added a couple of employee objects to it, and all the methods that are available to that object are also available to this object as well, right? It all travels together. That's pretty neat, right? So in other words, that employee class down here, since we had a ToString method, when I did the output, it was able to pull that information from those objects with its ToString method and put them up on the screen. So the company called Toy Factory, right, has Santa Claus's prez and the salary, and we can see it. Pretty nice. And notice it's even formatted as currency. How nice. All right. So that's our try it out, folks. All right. I'm going to keep moving forward, see how much more of this material we can hit. We're on slide 62. I'm who knows? Maybe we can finish this. I'd be amazed if we can finish it, but the copy pasting the code sure helps, doesn't it? Lets you move a little bit faster. The last time I did this, I think I hand coded everything from scratch, and I think I've learned my lesson there. All right. So we're going to learn another new concept now, which we're going to learn what an abstract is, and we're going to learn what an interface is, and we're going to utilize both of them to write some code. All right. So let's think about the word abstract to start with, right? And this is a really important concept, I think, in programming, because think about this. Whenever we create programs, they're all an abstraction, really, right? We're not really creating a physical thing. We're creating a set of instructions that get turned into machine code, which then turns into like electrons moving around inside a processor and inside RAM that does stuff. And I mean, none of it's real. It's all virtual. It's abstract. So okay, let's follow the example here. You can't walk into a pet shop and buy a pet. Right? There's no like, hey, show me where your pets are. Well, there is, but there's no pet that's called a pet in the pet store, right? You can buy a dog, or you can buy a cat, a bird, a fish, a snake, a lizard, whatever, right? Generic pets don't really exist, but specific pets do. It's an abstract idea, not a concrete thing. So the concept of a pet is not something you tangibly have until you have a dog or a cat or a fish, right? That's the concrete reality of your pet. And is my pet here? No, my dog is not here tonight. Normally she's sitting right there and I just reach down and pet her. She's like my security blanket or whatever. All right. So keeping on this. So if we don't have a generic pet in the real world, maybe we shouldn't have generic pet objects in our program either. So this is kind of an interesting concept. So why would you create something that isn't really a thing? This is kind of what they're pointing to. All right. All right. All right. So it's still useful to have a pet class, though. It captures all the general things that pets have in common. We just don't want to make any pet object. So in other words, I don't want to construct a pet in my code ever, because I could construct a dog or I could construct a cat. That makes sense. But I would not construct a generic pet. So what kind of stuff do pets have in common? You can see they have age, name, and like the speak thing that we talked about before, right? So we can actually change our class to be an abstract class by adding the abstract keyword, and you can see it there, right? So we just do this, public class pet, but abstract class, right? Now it exists only to be a superclass. So I can never directly instantiate it, only when I use the colon and the thing. So for example, I would never be able to do this in the program because of that word, right? But I can still use it as a superclass, right? So it says that default speak method is a bit silly. Do any pets really say hello, or do we just not have a good default? We didn't have a good default. All right. Point proven. So we can make speak also an abstract method, right? So in other words, all pets are able to speak, right? In the same way that the class is abstract, the pets that we create from this class can refer to the speak method, but we can never use it directly inside the object, right? So subclasses like dog, cat, and bird must implement it, but pet doesn't have to. So it doesn't have to be used. So we're not going to give it a default hello, because no pet says hello, well, except for my parrot, right? And actually, I do have a parrot, and she does know how to say hello. And apple, she loves apples, right? All right. So abstract methods don't have a body, just a header. So we don't have to write any code. We just list them as a method. The subclasses will override it with their specific information. So for example, the dog will woof, right? So if I go ahead, right, so now we enter into this concept, right? And I'm kind of stepping on my own tongue here, I think, a little bit, into what we call polymorphism, because this is a thing that goes hand in hand with inheritance and objects and classes. And this is a really fancy word. that means, as it says here, many forms. So a superclass variable can contain any of its subclasses. So the point is, right, if I instantiate a pet, whatever, but the dog is a pet. So the pet can take many forms: bird, cat, dog, fish, snake, lizard, you know, Sasquatch, whatever that pet is. All right. The inheritance doesn't work in reverse. So, like, once again, this is this concept we already looked at, right? The is a relationship is one way. The dog is a pet, but a pet is not a dog, right? You can't assign a superclass object into a subclass variable. So I can't do this. I can't declare it as type dog and then feed in a pet. Not going to work, right? Not at all. All right. So what I'd like to do with that one, if you guys don't mind, is we can do a quick little demo here with the pets. And I'm looking at the time, and I think I can pull it off, so I'm going to do it. All right, if you guys can roll with me here. So let's kind of compare a little bit of this stuff, and I think, if you guys don't mind, I'm going to pause the video here for a second. All right, we're going to start by building some classes here. So we're going to, even though there's not formally a triad out here, I'm going to build the objects that we need to do this, because we'll ramp it up as we kind of step forward. So the first thing I'm going to do is give you this code, and here it comes in the chat. I think it should fit. I think it all got in there, and I'm going to add that to my class definitions down here, and so these are all going to go up at the top, by the way. So for example, I'm going to build a class pet, and this is, you know, based a little bit on some of the stuff that we were doing before, right? So, you know, these are some of the examples that they were giving, right? That we have a name and an age, and then we have this method here called speak that we could override, and then we had a ToString method, right? So that's the one class structure, right? But it doesn't really kind of like match this abstraction piece. So for example, if I want to instantiate a pet, I can create a dog or a cat or something like that. So I could do something. In fact, maybe instead of coding this, maybe we just look at my other example here, right? So I could create a dog, for example, that pulls from pet, and then I can override that speak method, right? Because it's set to virtual. And instead of saying hello, it will bark. It'll say arf or woof or whatever. And this is kind of like a weird little sideline, but I always find it really interesting, like how every language, when they describe how a certain animal sounds, they all make different sounds. They're kind of the same. Like, how do you say, like, what dog does what sound does a dog make in Spanish, for example? I can tell you in Greek, we don't say arf or woof. We say rav, which is really strange, right? It makes no sense. All right. Here's another example of a cat doing the same thing. And once again, we're overriding that speak method to meow. And we can also override the ToString method as well, if we wish, right? And then you can create a pet lizard if you want. You know, that's the example. Now, if you look at where we're going with this next example, now I've got a separate version of pet called pet2. Same basic features, name and an age, get and set. We have a constructor that's allowing us to set the pet name, right? Well, if we construct a pet and we don't know its name, right, we're not feeding any information in, it's going to be unknown. Its age is 0. But then we have a two-art constructor that allows us to set those. We can send them in and set them. And then we have this abstract speak method, right? This is what we were looking at in the example, right? that we can override. So we don't define any code. There's no curly brackets. There's no actions we're going to take, but we're allowing it to be overridden. And we have a ToString method. So now if I'm to create a cow, for example, that uses that, notice that we can set up, for example, something that's custom to the cow. Well, cows have spots, so that's kind of unique to cows, right? Thinking like a Guernsey cow or something. And then when we create the cow, because this is a constructor here, right? We're going to send in true or false if it has spots or not. Some cows have spots, some cows don't. So that's going to be sent in when we construct, or we can construct the cow with its name, age, or its spots. And then notice, because we're using the superclass, the name and the age are actually set up here, right? We're drawing from it. And notice how the class is set to abstract. So remember that, right? You know, that feature as well. Then we're overriding the speak method and we're sending in a moo, because that's the sound that cows make, right? And once again, we have another override down here with ToString, but I want you to notice this is kind of interesting, right? Because we're overriding the ToString, we're using our own here, so we have to refer to the base class as well, right? All right, so that's kind of like a really quick little example of that. And then if you want to trigger all this stuff to run, here is my pet demo. You guys can screenshot the code if you want and try it, right? And first we did the regular version, and then we did the pet 2 version is really kind of what we did last time. If you guys want a really full built out demo of this, watch the last year's videos on it. But the point is kind of this, that we can build it on those abstractions. We can override the methods, and we can have objects inside of objects, you know, inheriting one from the other. The polymorphism happens, you know, in the way that we build all the objects collectively. All right. I'm going to press forward with the slides here, folks, because I think we can finish this tonight, which I think is a good thing, right? And that will allow us to operate in automatic mode. So the next topic is interfaces. And so interfaces are kind of an interesting thing, because we often have these needs, and you think about what the word interface even means, right? Like, for example, when I look at my computer and I want to interface with my computer, what mechanisms do I have to do that? That's kind of a good way to look at it, right? So I have a mouse, I have a keyboard, I have the screen, you know, camera, microphone. Those are objects I use to interface with the computer, right? All right. Now, interfaces are important because we use those as mechanisms, and we'll see the code in just a little bit, but let's do a little like thinking about this first, and let's follow through this sort example that they have here, which we're going to use in kind of the examples. So often when we're working with complex sets of data, we want to organize the data in a logical pattern. So for example, if I have a room of you like here in Zoom, right, because we're in a Zoom room, and I get a class list of my students, usually they're ordered by last name, right? And so the order that you're added to the class or whatever is irrelevant. Ultimately, I'm sorting you by alphabetizing your names, right? So for example, it says we want to sort a list of strings, or no problem. Lists have a sort method built in. So we can just call upon the fact that the class structure of string has a sort method attached to it, and we just utilize it, right? So for example, I build a string of instructors, or list of instructors, which is a list of strings, and then I add a list of people, right? And if I output that, we can organize it, and then we can run sort. And what sort does is this an alphabetical order? Yeah, it looks at the first character, right, to organize it. I didn't put them in alphabetically, but it sorted them into that order, right? So that's a method that's built in. right? Now, C#, it says, can sort simple types like strings and numbers. But what if we want to sort something more complex? This is kind of a weird thought. So for example, here we're looking at customer objects. So I have a list. Notice the list is not a list of strings. It is a list of objects. This is where it gets deep, right? Because now I can take that customer object, and what does a customer object have available to it? Well, it has the first name, the last name, which come from person. Remember that? That's inherited. And then the account number is what's unique to the customer that makes them different than a person. But I can add them to the list, and I can instantiate a new object as I'm putting it into the list. And that object, once again, inherits from the person class, right? And then we can sort that, right? All right. Problem is, this is an object. The sort method doesn't know, it knows how to deal with a string, sorting a string, it knows how to deal with sorting a number. It doesn't know how to deal with sorting a customer object, because that's not either one of those things, and it doesn't make sense. It doesn't know what to sort, basically, right? So this is kind of the point of it. So if I tried doing this and with the code that I showed you and then ran the sort, it wouldn't work. It would crash and it would throw this weird thing, right? Failed to compare two elements in the array, doesn't know what to compare. What am I sorting, right? So we can actually create this thing called an interface. So we finally getting back to the interface concept, right? An interface is kind of like an abstract class. We would never use it directly. This is the point. They contain nothing except for abstract methods. So an interface is a collection of abstract methods. Can't make an instance of it, but it's got methods, so I can use the methods. That's kind of the point. So if we want C# to sort our list of customers, you do that. We use this thing that we create inside of an interface called a compare to method. So we declare what we're comparing object to object. So it's like we're telling it what to sort, right? So compare to is our way of doing that, right? So in other words, when we're utilizing this, it says this is our guarantee to C# that the customer will have a compare to method. In fact, it won't compile until we add one, right? And so they use this keyword comparable to do this work. All right, so here's the scenario, and then I'll show you the code that goes with this. And yes, we will squeeze it in just in time. So how do I sort? Okay, your friend wants to help sorting his toy cars. You pick up two cars. What order do they go in? Are you sorting by year? Are you sorting by model, by color? Your Hot Wheels, what's the other brand? I forget. And so your friend has to teach you how to put the cars in an order that makes sense to them, right? All right. So what we do is we add this method to customer. So we're going to add this to customer, and it's a method called compare to, and we're going to use compare to and list the thing that we're comparing to. So what do we feed in here? A customer object. What are we going to compare it? Well, we're declaring it right here. We're saying the last name of our object is going to go compared to the last name of the other object that's being fed in. So what are we sorting with? Last name. So the compare to will tell us that we're sorting on last name. All right. So it says modify the dog class so you can sort a list of dog objects by age. So I'm just going to show you the code on this. So I'm going to find the dog object here. I'll show you the code. All right. So it looks like I did it with cow too. Let's find it. I'm sorry for all the scrolling, folks. I know that it makes people get a little nauseous sometimes when they're trying to keep track. All right. Well, it looks like I did it with cow instead of dog. All right. But I want you to notice that a cow, first of all, is extending the pet2 class that we created before, right? So whatever capabilities that had. Also, we're adding to it this little directive, which tells us that we are able to sort it. And so, Teresa, kind of going back to your question, it's not like we can include multiple superclasses, but it can include an interface, right? That's what we're doing here. And it's called iComparable. And what are we feeding in? Cow to objects, basically. We do have a compare to method that accepts objects of type cow2. And what are we sorting on? We're sorting on their age. That's what this is telling us. So this is kind of like the example of the how you build the object portion of it, right? Now, this is a regular constructible object, right? It's got regular methods in it. It has a data field in it. So let's find now the abstract class pet2, right? That has an abstract speak function. And I'm trying to find the interface here, folks. And just bear with me here a second through stuff. All right, so to run the interface demo on the cow thing, right? I would build some cow objects, and I have like cow2 objects, as you know, because I kept kind of ramping up. So I created a cow2 object called cow1. I gave it a name, I gave it an age. I made it moo, right? So this makes it moo. Then I create another cow, makes it moo. And then, okay, so we're doing all the sort examples here. We're done here from the example. But here I now have the cow sort. And what the cow sort is going to do, so I'm going to add more cows. So I have cow 4, cow 5, cow 2, whatever. And then I'm going to sort those. And then we'll output them. I'm going to run this. And this is going to be, well, I can't run it because I don't have it in Visual Studio. But the point of this is basically that it would be able to reach in there and do the sort because of that iComparable and the compare to method. And this is really a primitive a demonstration, you know, because you know, your homework doesn't really kind of go quite this deep. So here's what I'm going to kind of give you as a tip. So what I would say is, please look at last year's videos when you're going to sit down if you want to play with the examples. So I'm going back to our course shell here. So in the video area, you know, I do much more detailed walkthrough of that. So like I spent a whole hour, I just did about 10 minutes on it. I spent a whole hour just doing the interfaces and the sorting. So if you want to really deep dive into that, that might be a good place to start. Also, if you want to see the fully built out examples from last year, you could, you know, if you got the time, right? This is 2 hours, 3.5, 4.5 hours worth of lecturing there that you probably don't want to live through, but it is there if you want to kind of like rifle through it and reinforce a concept. Also, since we're not going to be here on Thursday in person on Zoom, the lab completion is in this video. And I'm just going to basically have you watch that video to replace what we would have done in class. It's 2 hours. Of course, you guys know you can fast forward it and rewind and whatever. But what I would compel you to do is, you got the time already like in your schedule. I would come to your computer at 7 o'clock on Thursday and run that video, right, and follow along and complete the lab. And then there were some issues. We ran into a couple little problems because we were trying to hotwire things. But if you flow through, we do get the solution. And what actually happened last time is I ran over class time, and I didn't want to finish without completing the exercise. So I stayed for like another 15 or 20 minutes and finished it. So the whole thing is there with the fixes and everything. And then there's this video here about the final project overview in the pseudocode, which I would also encourage you to watch on your own time. And if you look at that, that's about like one class's worth of material right there, those two videos. And then when we come back next week, we can review any of it if anybody had problems with it, and the codios and all that stuff. So this video will end here. I probably